Now we have the another definition of invertible function. F is a function from x to y is called invertible if there exists a function g from y to x such that g of f is equal to ix. Ix means identity function, and f of g is equal to iy, then the function g is called the inverse of f. Inverse of f, and it is denoted by f inverse. And now here f from x to y is invertible if there exists a function g from y to x such that g of f is equal to ix. G of f is equal to ix, that means the identity function. Now here the input is the domain of x, that is capital X, and outcome is again x. G of f is equal to ix, and here f of g is equal to iy. What is the input of f of g? Input of f of g, that means the domain of g. Domain of g is y, and therefore its identity function iy. Then this function g is called the inverse of f, and it is denoted by f inverse. In particularly, if f is a function from x to x and f of f is equal to ix, f is a function from x to x and f of f is equal to ix, then f is invertible, and f inverse is equal to f. Now we have some properties of invertible functions. Properties of inversible function या invertible functions. The first property, inverse of a bijective function. Bijective means 1 1 and on 2. Bijective function is unique. Second property, the inverse of a bijective function is also bijective. It means f inverse of its inverse is equal to f. Like the same, according to the matrices, A inverse of A is equal to A. The same properties that is related to the matrices. The third property, if f from A to B is bijective, then first one, f inverse of f is equal to IA, and second, f of f inverse is equal to IB. F inverse of f, either according to the second definition of invertible function, g of f is equal to IA, and f of g is equal to ib. Fourth property, if f is a function from a to b and g is a function from b to c, are both bisectives. Bisective means 1 1 and on 2. Then g of f is a function from a to c is also bisective. That means we can say g of f inverse is equal to f inverse of g inverse. G of f inverse is equal to f inverse of g inverse. Like the same, according to the matrices, AB inverse is equal to B inverse into A inverse, that is in the reverse order. And here in third one, according to the determinants, A inverse of A is equal to I, and A into A inverse is also equal to I. And now the fifth property, let A be a non-empty set and f is a function from a to a and g is a function from a to a, are two functions, such that g of f is equal to ia is equal to f of g. Then f and g are both bisective. Then f and g are both bisective and g is equal to f inverse. A is non-empty set, f is a function from a to a and g is a function from a to a, such that g of f is equal to f of g. Then f and g are both bisective, means 1 1 and on 2. When it is 1 1 and on 2, then g is equal to f inverse. Is it clear? That are the properties of invertible function.